All right. I think now is as good of time as any to get started. Um, so thank you all for joining us today. Thank you. If you're new to our Discord community, welcome to the Discord community. If you've been a member of the Application Discord community, we're great to have seen you for however long that you've been here. My name is Michael Salati. I am I guess I'm the only developer advocate currently at Application, so I'm the developer advocate at Application. Um, I've been in the world of software for roughly the past 7 years, but almost all of my experience has been either in developer advocacy, developer relations, or front-end engineering. So when it comes to back-end stuff or microservices, I am still in a place where I am learning a lot, and that's where, actually, funnily enough, Ariel, our VP of R&D, has taught me a lot over the course of this past week, and I'm really excited to have this conversation with him so he can teach you guys a bunch of the stuff he taught me and more stuff about microservices and backend architecture. So I'll pass it off to Ariel if you'd like to introduce yourself to our audience.
Cool. So hi everyone. I'm super happy to be here with our one and only developer relations advocate, Michael. So you know, right now we have one, and that's all we need. Um, cool. So my name is Ariel. I'm VP R&D at Amplication. In short, my job is kind of to be responsible for the engineering team, the technologies we use, the coding standards we have, how we document stuff, how we explore new technologies, making sure our cloud operations as well as open source operations are up to standards, and that at the end of the day, that we deliver the best product possible to our users. My background, I mean, I've been doing software development for a few years now. Started on the front end side of things, did some PHP, got into backend. Huge fan of infrastructure as well. So I kind of touched everything. I would say that these days I'm mostly focused on the backend efforts, teams, teamwork, all this kind of stuff, operations. Really love spending my free time getting into stuff like GitOps and Argo CD and Kubernetes and AWS and cloud. I wouldn't say I'm a master at anything. I would say I love kind of touching a lot of different areas and familiarizing myself with different areas. Yeah, I think that's about it.
Awesome. Welcome. And you're also, I want to say new to Application, but by new, I mean like it's been a month, maybe 2 months now. So for those of you joining us today, Ariel's our second most newest member of the team. So this is really exciting to have some fresh insight and stuff like that. I will also add real quick, we will be taking questions. If you have any questions, be sure to leave them in the chat. We may answer some of them in real time, or we may save them to the end. It kind of just depends on how things go and what the flow of our conversation takes. But we will be sure to hit all of the questions that you guys have. So just getting started, at a very high level, what exactly are microservices and why should we care about them, I guess?
Okay, cool. So microservices before anything is just an architecture, right? You have a lot of different architecture types and ways to implement architecture. And when you talk about microservices, really what we're talking about is microservices architecture, which, in a way, it means that when you develop an application, let's look at this box as an application. It will consist of small services or business unit oriented services, domain oriented services that are independently deployable. They can be maintained, developed, and tested independently. Again, as I said, they are usually related to a single kind of business domain. We're going to talk about that a bit later. And because of all these reasons, it makes them very easy to maintain in the long run and maintain end to end. So from start to finish. That is it in a nutshell. So basically, when you go for microservices architecture, you'll say, instead of deploying all of my business logic and stuff like that under one process, one application, I'm going to divide it into services that are specialized in a specific domain, business area, specialty, and I'm going to test them, maintain them, deploy them all independently.
So, like at a high level, like you're separating the different separation of concerns is like the phrasing that comes to mind, where
Right.
different components or things that do different things are developed, deployed, and managed set independently of each other, right? Like that's a
Correct.
decent
Right.
description.
And
Okay.
exactly. And I'd say, some of the perhaps obvious advantages that come to mind when you hear about these, what microservice architecture is that it really allows teams to independently own something, um, you know, not have to be blocked from like a technological point of view. They can use whatever tools they want for the job. They can deploy independently, and at the end of the day, they have less dependency on each other.
So, okay, you said that that it gives teams this ability so they're not blocked by each other. They can choose their own tech stack. And so I'm assuming these are things that aren't as common in what we'd say is a more traditional application development. So how does this compare to traditional application development? Or I think it's the concept is like called monolithic architecture. Is that right?
Right, exactly. And maybe we can quickly go over what a monolith is for those who maybe are writing a monolith and they don't know.
That would be a good
So
idea.
yeah, let's start with an example, right? So you have a fantastic idea for a side project. You want to build an e-commerce website. You open up your web editor, you do npm init, you start coding in Nest or Node or Express, whatever framework you like, and you start building your application. And, it's a bunch of endpoints, and you want to accept orders, and you want to manage baskets, and you want to ship orders, and you want to have user management and all that good stuff, and you're piling up endpoints and endpoints and endpoints. That is what would be considered a monolith. So it's one single application that is delivered to your users as a single sort of deployable thing. It is a single deployable, and it can do a bunch of stuff regardless of business domain or functionality. That is a monolith.
Okay. And so that makes sense to me. Why would I want to do microservices over the monolith? Like what are some of the issues that we might have with monolithic app development?
Cool. So I want to put a disclaimer here and say that microservices is not right for everyone, and I guess we're going to get to that a bit later as well. So we're not trying to say that microservices are the absolute go-to solution, but let's talk about that. So let's talk about some of the disadvantages of monoliths and when they become problematic, and that kind of leads us to why we might want to try using microservices in certain situations. So again, you're growing your application, you're adding more and more logic. Perhaps you're just a business trying to find product market fit, right? You're starting small. You want to ship features really, really quickly. Monoliths really give you that, right? You just open up the code base, write that feature in, but then it grows and it grows, and you maybe hire more developers, you get more team members, perhaps your team split, they have different product goals and stuff like that. And at the end of the day, when you write a bunch of code in a monolith, and add more and more functionality to it, what happens is that it becomes a really huge code base. You can imagine one team wants to use a certain validation library, and then the old validation library is different. So then you think, how should I use this? Should I use that? Version management of certain dependencies. Release blockers, right? I'm sure a lot of our engineers in the audience definitely remember scenarios where their team was ready to ship something, their product manager was happy, they really needed to ship it at a specific day, but because of something that broke that a different team has done, they couldn't do that, right? So that's one more sort of, you're all probably familiar with this problem when working on a single project with multiple teams. So there's a lot of dependencies. They are not just code, they are process, right? Technology. What if I have this monolithic application and I want to, wait, let me just mute somebody. Yeah, there we go. What if I have that monolithic application and I want to incorporate a machine learning pipeline, very specific sets of tools that perhaps Node.js is not really right for, right? Or maybe I want to do image manipulation, right? And maybe there's a different tool to handle that. I'm not saying you should, but I'm saying in certain cases it would be right to use the right technology for the job. And when you're committed to working on a single code base, this becomes impossible sometimes. Are you going to stop using the technology that your team is used to? Or are you going to give up on using a technology that will make it super easy for you to plot graphs or do machine learning and data processing. These are some of the disadvantages in a monolith. It's not very easy to scale. And I think perhaps one more important point is when it comes to redundancy, right? Think about it. You buy an apartment, right? Your apartment has a sofa in it, or you need to buy a sofa for your new apartment. How many seats should your sofa have? You live together with your partner or your wife or husband in the audience and stuff like that. How many seats should your sofa have if you're just two living together? Do you want to have some redundancy? Should you have like 20 seats? Should you have two? But then when friends come over and visit you, you don't have any more seats. So the problem with monoliths is that if you have a huge code base that deals with a bunch of functionalities like order processing and shipping and catalog and caching and all that, you're scaling the entire monolith regardless of how much load and traffic each module of your monolith consumes. So you're paying a lot of money to upscale things that perhaps don't need it.
Yeah. So taking the shopping site into account, like as an example, you mentioned that there's be something for like where the catalog is of all the items for sale, something that manages carts, something that manages transactions, API endpoints something that manages like, okay, items have shipped and notifying users of updates in the status of their order. And let's say it's a holiday event or like Black Friday, where all of a sudden you have hundreds of thousands of millions of people hitting your website trying to buy things. And so you might want to be able to have more instances of your application running that can serve the catalog and serve transactions. But you don't need to worry about shipping right now. You're just trying to take in a lot of orders real quick. And so what you're saying is like, if the monolithic architecture, you don't get to pick and choose what things you need up and running. All of them have to be up and running. And if one of them increases, like the traffic, all of them increase in traffic, right? Like, is that a kind of a decent issue, a decent way to describe the scalability issue?
Correct. And I think I want to go back to one of the examples that we talked about in one of our previous chats. If you have a shopping mall and you have one shop in that mall that faces a lot of traffic during lunchtime because it sells very delicious sandwiches made by our dear Michael Solati, everybody wants to go there and get those sandwiches. Well, if you face a lot of traffic to the point that customers cannot go in, you might want to increase the size of the shop, or you might want to hire more employees and stuff like that. So in a monolithic world, what you'd end up doing is basically copy the mall rather than perhaps create more shops in a city or in the mall or whatever to distribute that load. So this is the kind of redundancy I'm talking about.
Yeah,
you don't have granular control over what part of my application requires that scale.
I get it. I'm a coffee addict. I'd love a Starbucks on every corner. So I understand needing to scale up individual things rather than the entire everything, I guess.
Right.
So these are some of the disadvantages on monolithic architecture. And we kind of like tied that into microservices, but let's get a little bit more specific, I guess, as to what exactly are the advantages of microservice architecture.
Cool. So again, this is a great time again to say that although there are sort of objective advantages to microservices, I think somebody mentioned that in the chat, and we can talk about it a bit later. It's not always the right answer. It doesn't have to be extreme either. There is some middle ground that we can talk about as well. So I would say advantages of microservices. So I can tell you from my experience, I've worked for a company called DAZN. Some of you folks might know it. We grew really quickly back then, and we had teams that are dedicated to specific business domains. So you can think about stuff like authentication, authorization, landing pages, my account management, catalogs, video streaming, and stuff like that. And trying to imagine us working on this kind of functionality in one monolith would be absolutely impossible. One of the greatest things that we got from using monoliths is the ability to ship independently. So a small team, seven people, focusing on a very specific problem that they solve, and having ownership over the backend services that they need to solve in the form of a microservice allows them to make decisions very quickly, choose the right tools for the job very quickly, experiment with stuff, right? A new technology comes out that can do form validation really well. Well, I can experiment with that as a team. I don't have dependency on other teams, and I can share my knowledge with other teams. So it also promotes engineering excellence and a great engineering culture. I can hit the push button and push it very quickly. I would say, again, from a redundancy point of view, as a team, I have full ownership and full knowledge over, how much does my billing service consume? What's the traffic looking like? How do I scale it independently of the rest of the architecture? So it gives teams and perhaps, groups of people a lot of autonomy over sort of how to full ownership is the right word to say that. End-to-end ownership, testing, developing, conventions, and this kind of stuff.
Yeah. So that sounds all fine and dandy, but I'm imagining there have to be some disadvantages. Like, based on what you described now, like, yes, owning unit tests is something that you have better control over. But then I'm starting to wonder, like, oh, what about integration testing? Does that become a pain? So I'm imagining there are issues. Can you highlight some of them for our audience?
Totally. So I think somebody in the comments said, I feel the cost of microservices could be expensive for a small team. And my answer to that is, absolutely. If you're a team and your entire focus is to find product market fit and all you need to do is ship features and get feedback and get data, then it might not be right to just go and split into microservices. So that's like the short answer. The big answer or the large answer is long answer. The long answer is there's a lot of complexities that get introduced when you work with microservices. So if you're used to having a monolith and you deploy it all under one thing, it's very easy, very simple, one pipeline, hit deploy, everything matches. If one function has a dependency on another function, it just calls it internally, and it's always guaranteed to work because it transpiled or compiled. Well, suddenly you might have services that have some loose dependency on each other, and one of them can be deployed while the other still expects a different shape of data or data schema. That's going to be a problem. Your users won't get service, right? Operations, right? I mean, you're going to have to take your operations delivery pipelines more seriously because you don't just have one pipeline you need to deploy. Your cluster might get a bit more complicated, networking, network partitions, this kind of stuff. So again, all of the consequences of not having just one thing that runs in a process. As you said, integration tests. I mean, you're not at the point where you can call a function and make some mock or check if something has been called. You're actually on a different process. You depend on something else that's not, you don't have the direct ownership of that, and you don't have the guarantee that it will always serve you the data that you need for your service. So, these are some of the complexities that come with microservices. And I'd say the moment a team or a group of people decides to split, they have to be ready, and they need to have the knowledge and hopefully the experience as well, at least some of the team members, to understand, first of all, make the decision. Is it right? Are we ready for that? Are the gains we're getting from microservices right now worth the effort, the extra effort that we're gonna, and at the end of the day, you're gonna deliver less features because you're gonna have to spend a bit more time on having a scalable, fantastic architecture, but you have to do it right.
Talking about architecture, and definitely because there's multiple stakeholders, multiple teams working on different components and different aspects of your backend. Like architecture and planning things accordingly, I'm assuming are super, super important. So like, what are the thoughts or the things we need to know about API architecture in this world?
Cool. So I'd say from an API point of view in itself, not much changes. Let's kind of split it into two. Let's split it into, a great question that somebody asked, which is communication between microservices, and then, sort of public-facing microservices. So let's take the example of an e-commerce website where you can have different areas of ownership conceptually, like a catalog, like your landing page. You could have a basket management system. You could have like the whole generate invoice, take payment, generate invoice, send an email kind of thing. These could be separate services, right? So let's look at public-facing ones. As a user opens up their browser, they go onto your website, and they see a catalog with all of the great products and sandwiches you have to sell. This is a public-facing API. You would do it the same way you do it with a monolith. You would have a REST API or gRPC API or perhaps a GraphQL API. Not much changes there. What could change sometimes is there is a pattern that I don't think we should dive too deep into, but it's called API gateway. Sometimes, to fully complete an operation, you might require a sequence of requests to microservices to complete successfully, because perhaps you depend on data coming from one microservice and a second one and a third one. Let's take an example. You need to generate an invoice. So that's a request going to your invoices service. And then you need to send an email. That's a request going to your email service. So you need to guarantee a sort of order and success of that order of operations to complete that feature. So you normally don't want to let your user's browser handle this kind of stuff because they can tamper with it. And you might not want to expose how your architecture works from the inside. So then normally what's common to do is to put an API gateway in front of that. So your front ends interact with API gateways, and the API gateways will do whatever whatever is needed. And then they can do retries and rate limiting and authentication and authorization and all that good stuff. And this can also be achieved with something called GraphQL Federation, which is a fantastic technology. But that's the idea.
You did mention about how some of the internal services kind of communicate with each other, like placing the order and then sending confirmation email. And you didn't want the client to handle that. So this is happening on the server. But these end up being different microservices. And I'm assuming this is kind of a challenge addressing the communication, because each service is kind of separate and independent from each other. So let's talk about the communication a little bit. Like, how do you handle communication between the microservices then?
I think that's a great answer, a great question. And when you split your monolith into microservices, you get into this new world where you cannot just import a JavaScript file anymore and say import my email module and call a function called send email. That's just not possible anymore. So yeah, there are challenges there. Communication between microservices is, in my opinion, and I actually had a talk about this last month in NodeTLV. I think this is one of the most common, if not the most common, kind of pitfall where certain teams or engineers adopt microservices architecture, but they don't quite know how to do communication right. And if you don't do communication right in your microservices architecture, and you don't know the difference between synchronous and asynchronous operations, and what the trade-off is of using synchronous or asynchronous for specific operations, well, then you're not going to have a great time. It's going to be hard, and you might make some mistakes that might be expensive, maybe not. But yeah. So back to your question.
I would love to go back to my question, but I want to pause you right there, because you mentioned the difference there's a difference between synchronous and asynchronous operations. And in our previous conversation, I thought I knew what async and sync was, but I think in the context of microservices, it's a little bit different. Can you at least describe what synchronous versus asynchronous is, at least in this context? Because as a front-end developer, I think it might be different than it was different than what I initially thought. And so I'm thinking our audience might run into that confusion later.
Right, and we're gonna oversimplify it as well. So as a front-end developer or as a JavaScript developer, you think of like async await. If it says await, and it must be asynchronous. Well, it is from a Node.js event loop point of view, but from a microservices or distributed system architecture point of view, a synchronous operation is an operation that you initiate, and there's always a response coming in. Sort of, you wait for the response to come in, and it will come in, right? And an asynchronous operation is an operation that you will initiate, and you're not directly waiting for the response. So it will happen perhaps later. And when you truly understand these, the tools that you can use to achieve either synchronous or asynchronous in a microservices architecture, then you'll have a great time developing a super robust and scalable system. So for example, when you have a microservice A and microservice B, and microservice A sends a HTTP request to microservice B, just like we do between front end and back end, the good old HTTP call, that is following the request response model, and that is synchronous, right? There are some problems with that. For example, it takes a while. If you have a series of those requests, you're going to end up with like a lot of latency, or it could fail, right? So if you have 3 microservices you depend on to complete an operation, loosely depend on, and you make a request to one of them, say generate an invoice, and then you want to send an email, but the request to generate an invoice failed, then you cannot generate an email. Just because the invoice service was for just a second not available, then your architecture is not very resilient. It will not be able to handle failure. And that is some of the disadvantage of synchronous stuff. Whereas with asynchronous stuff, you usually do things in different techniques that I'm not sure that it would be wise to dive deep into them. Later on, we can, let's mention some of the names of those techniques just now so that our folks can write them down and maybe read about them. So when you get into, so you understand that synchronous operations do not scale very well. They are expensive to scale, actually, because if you send a request and you always depend on a response for a particular service, then you're doing things immediately, and you have a spike in your traffic, then you need to really scale up that service a lot, and that's expensive. When you get into the asynchronous world, you find methods and ways that allow you to sort of initiate an operation, and you just continue working as a service, right? You just continue doing your stuff, and you don't wait for a response immediately. The response might not come back immediately. It might come back in a minute, in 10 minutes, in an hour, depending on what it is. And maybe an example would be of when I would use a synchronous operation and when I would use an asynchronous operation would be if I need to do something and guarantee something right now, otherwise bad things will happen, like changing a password, right? I would use synchronous operations because I know for a fact that just succeeded and I can return my user a 200 response and everything is good. But if I want to generate subtitles for a video that got uploaded by a user, that is a very resource-intensive operation. The machine costs me a lot of money, and I'm totally okay with doing that over a few hours, maybe a few minutes. You can see that when you upload a video to YouTube, you don't always get the highest sort of quality right away. That is because asynchronously, they will generate higher sort of quality versions of your video. So that is sort of when you would use which. And for those that are curious to read more about asynchronous, technologies and tools that you can use, you could use stuff like message queues. You could use pub/sub messaging. You could use event streaming. Feel free to Google for that. And hopefully, when my talk from last month will go live, I'll be happy to share it with the community because I dive quite deep into those tools as well.
I definitely think that's going to be, for me, that's something I want to learn more about because it's conceptually different, but I think I understand it enough. But I want to see more because this definitely sounds like an interesting, at least change in thinking as a developer for me on how to handle these things. But yeah, so we were kind of talking about challenges. We diverged a little bit. That's kind of my fault. So pulling it back in, reining us back into the first question is like, what are some of the challenges or greatest challenges that you have faced while building microservices? And I think we hit on communication, but if there's other things, I'd love to know them.
Cool. Yeah. So again, communication is one of the very obvious ones. If you don't do communication right, then you're pretty much bound to either pay too much or have bad things going on, like repeated messages or unavailability and all that stuff. So messaging is one of them. I would say observability is another big issue. You don't have that single application that you can console log to anymore. You might have an operation sort of jumping through multiple microservices, and you want to have a clear idea of when that operation starts and when that operation ends, and every stop along the way, what happened, how long did it take, is the latency okay, is the response as expected? So observability and monitoring and all that kind of stuff becomes really difficult when you leave a single process and a single monolith. Tracing, right? So if folks that are interested to read more about that can search for tracing in microservices. There are some fantastic tools online like these. There are solutions to that, right? Distributed tracing. How do you track a request all the way from the user's client to service A, B, C, D, E, F to the database and back? It's really fun to do, and it's really awesome when it works, but it is a challenge.
Mhm.
Another one is databases, right? When you get into, and this challenge is also a benefit, right? Because when you use a monolith and you use, I don't know, Postgres or MongoDB, you use whatever database you use, then that's going to be it for the rest of the application's lifetime. But when you use microservices, you can use different types of databases for different purposes. So obviously, NoSQL and SQL have, can do a lot of things that overlap, but a lot of things that they can do don't quite overlap. For example, if you're designing Uber and you need to work on the microservice that distributes deliveries and based on location, then MongoDB would be a better tool because it has geolocation-based querying, for example. So it's a challenge because you have to sort of care for sometimes different databases, cache layers, all that. But it's also great because it allows you to choose the right tool for the job, get more speed, maybe lower your costs sometimes. Yeah.
I actually want to jump on. I think we're kind of wrapping up on the conversation between you and I, but we had a question that I think is super relevant to just what we were discussing. So, Anime Shikstas, I'm butchering that. Anyway, they commented or asked, I believe that you mentioned that communication between two services is not in JSON mode, so debugging might be difficult. And I guess they're curious on. I'm not sure the best way to phrase that, but I think they have some questions that maybe I don't know if you see the
I saw that. Yeah.
Chat comment. Yeah. If you want.
So I'm not sure if I'll be able to answer that question directly because it's not quite clear to me, and I want to say why. So I mean, JSON is just how you structure your data when it travels from one point to another, whether it's a HTTP call or, as somebody said, Kafka or RabbitMQ or Redis or whatever. It's just a form of how you store your data in UTF-8, right? So that's JSON. You can still use JSON in a microservices architecture to communicate through Kafka or a message queue. Pretty much most of the time, you will use JSON just because it's easy and it's agnostic of technology. And then debugging is a different topic. So I don't think it has a direct relation to JSON. Debugging is hard because when if you're used to opening up VS Code or WebStorm and using the debugger, then you only debug a specific service or a specific process. So yeah, you cannot quite directly debug, the way you're used to from one microservice to another. Maybe there are some interesting tools that allow you to do that. Maybe remote debugging. I'm sure there are some tools in the market, but yeah, I don't think it's quite related to JSON per se.
Okay. I kind of said that this would just be a quick question, but you want to dive into some of the questions because we've had an active audience, I think, and
absolutely very active. And thank you all for that. It's amazing. You're an amazing audience.
All right, so I'm scrolling to the top to look at what we got. So, not microservices related, but Solus asked, what is the tech stack at Application? Off the top of my head, I know that we build Application with Nest.js, GraphQL, Apollo, Swagger, React for the admin panel, but I'm sure there's other things that our audience might not know that we use. If you can share the secret sauce on what makes Application so special.
Cool. So I'm going to divide this answer into two as well, because I want to give you a bit of information on what we use inside Application and also what we use when we generate code, right? We're open source, you can see that, but I'm going to say that anyway. So maybe this is also a good opportunity to see that microservices is something that we see and hear that you folks really care about. Some of you prefer to stay in a monolith, some of you really want to grow into microservices. So I'm just going to mention it here and say that we're putting a lot of focus to make sure that we enable microservices. This is something that we work on like every day, so that we can provide an amazing product to people using a variety of architectures. right? At the end of the day, we want to help you code what matters and focus on applications, whether they're a monolith or a microservice. And we want to enable you to split into microservices if you wish. So just know that. In terms of technologies that we support for generation, yeah, we support generating REST APIs. And for those, we also generate a Swagger file, so an API spec file. We support generating GraphQL APIs. So, for that, it's self-documenting, so you don't really need a Swagger file. We use Nest.js internally, as well as, what we generate. We would love to support more frameworks and tools and languages, perhaps in the future. We do use microservices. So we have a few microservices. We deploy to the cloud. We use Kubernetes. That's sort of it. We use a monorepo that I can tell you. Right now we're using Lerna. So a pretty fun tech stack, I'd say. One of my favorites.
Another question from our audience is from Tushar, and they ask, have you ever faced a problem while working with microservices, and how did you solve it? So I think we discussed some of the difficulties, but is there some a specific story when the server went offline or something? I don't know.
I'll try to keep the story short because it has some details. So let's see if I'm good at simplifying stuff. But yes, actually a million times. But a specific one that I remember is that I needed to design a live streaming service for a business that really suffered from COVID and needed to go full digital. And as a part of that architecture, we had a few components, but the ones that are really important are the downstream service where users download video chunks and where the people who stream the video can see how many people view their stream. Sounds pretty easy, but it's really not. If you want to do microservices, you need to choose a streaming protocol that does not have a constant open connection. So we went for HLS. The way HLS works is you send a request, you get chunks. You send a request, you get chunks. And it's very, like static files, basically. We serve static files instead of having an open connection and a stream constantly streaming in. This allows you to scale and load balance and all that stuff. Now, the problem of that is because you don't have a constant open connection, you cannot really track how many active connections you have. So what we had to do is put a cache layer in the middle where every time somebody asks for some chunks, we kind of ping the cache layer and add a time to live period, another 10 seconds, another 10 seconds. Then basically, the moment a user stops asking for chunks, they're going to disappear from that cache layer, and then we know what to serve to the viewer. So it's not perhaps real time, but it's very close. There were a lot of challenges with that. I mean,
that sounds awful. I get it. I get how that works, but that just sounds like a pain.
Because it's not very intuitive. Your intuitive thing is somebody's watching my screen, so the connection must be open, right? But it's not. Everybody there was new to streaming. I mean, scaling, for example, most microservices use the same machines, right? You're serving in a web API at the end. But then there, we had to suddenly understand we're doing video streaming here. We have different machines that we need for video streaming if you want to make it fast. GPUs, graphic cards. How do you scale them separately? How do you put them in different Kubernetes nodes? I don't want to dive too deep into the details, but there's every project has its own stuff. Everything is solvable. That I'm going to tell you that. Everything is solvable,
sure.
But it's not always as straightforward.
So Anthony Parker asks, what message queue would you recommend, Rabbit or Kafka?
Oh man, I'm talking about this in my talk as well. So I think it's just for a second to say what a message queue is. By definition, a queue is somewhere where a party would put messages and a different party would consume messages at its own pace, right? Many people confuse it with PubSub and messaging and streaming. Message queue is not made for real-time stuff. It's made for when you want to throttle down stuff, like with a subtitle generation example, or generating high-quality videos over time. You want to throttle down stuff because you know the machines that are handling it perhaps are too expensive, or it's not so critical to do it right away. So you can save a lot of money by doing that and be very resilient, right? So that's what we use message queues for. Why resilient? Because if a service goes down, it comes back up and it continues reading from the queue. It's not synchronous, it's asynchronous, right? So For AWS, I highly recommend using SQS. So if you're using AWS as a cloud service, SQS is fantastic. It's super simple. It's very, very cheap. You have like 1 million free messages per month, right? I would say RabbitMQ was made to do that, and it does that pretty well. Kafka, I think, is better in many aspects, but it's more difficult to operate. It's more complex. It's more expensive at scale. But it has some great other capabilities like real-time data processing and stuff like that. And with Kafka, you can replay messages. So if your architecture went down and you want to replay all the messages from yesterday, you can do that on Kafka, and you cannot do that on RabbitMQ. I would say RabbitMQ is very simple. Go for that. If you're on the cloud already, I would go for something like SQS on AWS.
All right. Tushar asks, how can Docker help in microservices?
I think the problem that Docker solves is definitely relevant to microservices. So Docker, for those who don't know, and again, I'm going to keep it really simple, is a way for you to pack your code instead of running it like you run it on your computer in dev mode and say node, whatever JavaScript file. You'd pack it into a Docker container. That container runs an image. The image is configured to install all of your dependencies, whatever. It's based on some architecture, for example, an Ubuntu machine. So it basically gives you a sandbox environment that is, first of all, very secure. It's very reproducible. You know, the whole, oh, it doesn't work on my machine problem kind of disappears when you use containers, because you have a guarantee that a software that runs on one container would run exactly the same on a second container.
Yeah.
So just for that reason.
Howling?
Sorry?
Is that a wolf howling in the background?
Possibly a child
Okay.
at the street. Let me close my window, sorry.
No, I just heard a howl. I'm like, oh my God.
Yeah. We don't have wolves. We have 3 wolves here in the Netherlands, and they often go to Germany when it's too warm. So yeah. Anyway, yeah. So I'd say Docker containers are amazing. I think if you design your applications to be served by containers, at the end of the day, when you deploy your microservice, you deploy a container. Pretty much in all like common microservice implementations, and it's great because if your containers can communicate between each other, then you know they're going to work on the cloud as well. It makes everything reproducible and predictable, and that's a great benefit.
Yeah, because I guess like trying to simplify your simplified answer in regards to the Docker thing is basically you're defining what computer your code is going to run on, and so that way
operating system rather.
Well, yeah, it's your operating system, the dependencies that you need. You can define all of that. That way, when anyone runs it, they have the same exact environment and experience, which we actually do that with applications. So if you run application locally, you run, I think, your the application server code and the admin.
Absolutely everything. All of our microservices are Dockerized. Database that we use, Postgres, is Dockerized. Kafka is Dockerized. It's a very reliable way to let developers just run a single command and run the entire infrastructure they need in a very predictable way.
Got it.
Yeah.
All right. Next question by I believe it's Sajith. Is different code bases using the same database, can that be considered a microservices or microservices?
So for a microservice to be considered a microservice, it needs to be independently deployable. If you can deploy microservice A separately from microservice B, then it is a microservice. Whether it's right to share databases is a whole different thing. I guess if you Google for it, you'll find the religious answer that says never share databases between microservices. I sort of agree with that because I think if you end up sharing databases between microservices, maybe you've done some oversplitting, and maybe it's best to just keep it as one service. So yeah, I would say if it's independently deployable and it contributes to the flow of your functionality, then it is a microservice. Whether it should use the same database as another service, I'm not sure about that. I would personally avoid that. It shouldn't be the go-to practice, let's say that.
Okay. And I think this is our last question. Actually, no, hold on. There's two-ish more questions. And I think we're going to cut it off there because we're getting close to time, and this might push us there. So Pranja asks, is there anything particular that needs to be considered if planning to migrate from monolithic application to a microservice?
I think that's a fantastic question, and I can see the audience likes it as well. And I think it's great that you asked that because I wanted to say it and I forgot. So looking back at like the beginning of this conversation where I said it's not so extreme. You don't either have to fully go for a monolith or go microservice. You can also build your monoliths in a way that would be easier to break into microservices. So if you use something like Nest.js, the module system at Nest.js, dependency injection, all that stuff makes it a million times easier and more natural to develop applications. That when it's time for this application to become a microservice, you can take that and turn that into a service of its own. Yes, you're going to have to connect some wires, but if you folks have seen a variety of Node.js Express applications, you know how difficult it is to do dependencies and dependency management, right? So in short, if you develop your monoliths or services in a modular way, as in within your code base, single responsibility, sort of single entry point, pure stuff that are independently testable, then yes, you're going to have a great time splitting into microservices. And then I would say, when the time comes for you to split a certain business unit or domain or functionality into a microservice, then you can look into opportunities. Can I introduce TypeScript here? Is it going to make it more robust? Should I use a different database? Do I need a cache layer here? And stuff like that. But modularity is a great way to make sure that when it comes, to splitting into a microservice, then you're going to have an easier time.
And our final question that was asked by Anthony, can you talk a little bit on securing messages across different services?
Cool. So I'm not a security expert. Let's start with that. But I'm gonna sort of tell you what I think and what I would do before I ask for an advice from my beloved security experts. So at the end of the day, communication within, let's say you deploy your microservices into a cluster. First of all, you want it to communicate internally, right? So any communication that's going between your microservices, whether it's through a message queue or direct HTTP calls, you want it to happen in a closed network, right? Unless there is a really good reason not to do that. If you depend on an external API, for example, that's out on the web, that's understandable. But by default, within your cluster, within your AWS VPC, whatever, you want to keep things internal and closed. The second thing is you want to use TLS encryption, so HTTPS. It's a very reliable way to encrypt messages, even between your cluster, within your cluster. Send HTTPS calls. Make sure that every one of your microservices, has a TLS certificate, and then your messages are going to be much more secure. If for whatever reason you still think you need to encrypt messages, then you can use any encryption algorithm you like. Produce keys to decrypt. I think that's a bit of an overkill, but perhaps certain applications and certain regulatory needs would require you to do that. I would say anyone should know how to safely store sensitive information regardless, how to anonymize information, how to make sure that passwords are stored properly and stuff like that. Hopefully that makes sense.
I think so. And I think we are getting close to time. So maybe now is a good of time as any to call it for today. So I will say thank you all for joining us. If you have any questions about anything you heard about today or anything else whatsoever, write something in one of our channels. We have channels for feature suggestions, bug reports, and just general chat, which can be about whatever. I think I recently saw a thread with people recommending podcasts. So feel free to leave questions there. You can tag either myself or Ariel if you have any specific questions. And I'll say thank you all for joining us today.
Yeah, thank you, everyone. It was a lot of fun. I think there's some great questions here. So thank you for that.